Alrighty, now on to rotations. This is another type of transformation. A rotation is a transformation in which a figure is, and you can probably guess, turned or rotated about a fixed point. And that fixed point that we're going to use the origin 0, 0 as our fixed point. So everything we do in here, just know it'll probably say, like, you know, use the center of origin or 0, 0, and that's just kind of like a given. We're always going to be rotating from 0, 0. Now, here are some more rules that you need to memorize when you're doing rotations. For a 90-degree rotation, A to B, and again, this A to B, this is also X, Y. Sorry, I didn't catch that beforehand. So same, those are X, Y. So when you rotate 90 degrees, you're going to take the opposite of Y, and it's going to become your X, and the X is going to become your Y. When you rotate 180 degrees, you're going to take the opposite of your X and the opposite of your Y. Rotation of 270 is going to be your Y is going to become your X, and your X is going to be opposite. So those are the rules for rotations. Now, it is understood that rotations will be performed counterclockwise. Unless it specifies in another way, but it should be counterclockwise. And the reason this is because this is the order that we label the quadrants. So remember the quadrants of the coordinate plane, like this one is 1, then you have 2, then you have 3, and then you have quadrant 4. So remember to name the quadrants on the coordinate plane, you make a C. All right, so that's why we're going to rotate clockwise, is that's the way things are labeled. Let's look at example 1. They would like us to graph the quadrilateral KMLN with those vertices and then rotate it 90 degrees about the origin. So let's plot the points. All right, there is quadrilateral KLMN. Now we're going to rotate it 90 degrees. So remember, when we're rotating 90 degrees, you're going to take your ordered pair and you're going to change it so that you take the opposite of Y becomes your X and the X becomes your Y. So let's do that to all of our ordered pairs. So we're going to take the opposite of Y and keep the X. The opposite of Y, keep the X. The opposite of Y, keep the X. Opposite of Y, keep the X. Now plot those points and you will see the 90-degree rotation. So there's what your quadrilateral should look like after the 90-degree rotation. Remember, this is our old, this is referred to as the pre-image, and the new one is referred to as the image. And also remember, the new one has the primes after the little apostrophe after the letters. All right, number 2, identify each type of transformation. So from picture A, how did it get to picture C? Well, it's really facing the same direction, so it just went right and then down. So anything moving left, right, up, and down is just a translation. And then we have from C to D, and you can see from C to D, obviously it is turned. So the transformation that turns objects is called a rotation. Now, we've talked about this before, but an isometry is a transformation that preserves length and angle measures. In other words, an isometry is a congruent transformation. So all of the transformations that we've learned about thus far have all been isometries, and you can see here that a rotation is an isometry. When they took this image and they rotated it, it stayed exactly the same size. When you translate, it stays the same size. Same thing, they reflected it. All right, it all stayed the same exact size. So we call that an isometry. It's a congruent transformation. So with that being said, the quadrilateral is rotated. So here's kind of our key word. It's rotated about point P. Find the value of y. And I'm going to go ahead and let you know we're going to also have to find the value of x before we find the value of y. But since it's a rotation, that means it's an isometry, which means everything stayed the same exact size. So if we need y, there is 7y. Well, if that shape was rotated here, that would match up with that expression. So we can't really find y yet because we can't mix the x and y, but I see another x right here, and it corresponds to this side. So I can set up an equation there saying 3x equals 6, and I can solve for x. Now you take that x and you plug it back in here, and you have 3 times 2 plus 1 is equal to 7. So this side now is equal to 7, which is coordinating to the side that has 7y. So if you divide by 7, your y is 1. And that's all you have to do. Again, this is just testing you to make sure that you realize that these types of transformations are isometries. Okay, number 4 is just a little bit of a review. So triangle A prime, B prime, C prime is the image of triangle ABC after a translation. Write the rule, then verify that the rule is an isometry. All right, so we just pick any point, A, B, or C. It doesn't matter which one. So if we go here, we're saying, okay, how did they travel along the graph? They went back 1, 2, 3, 4, 5. So that's back 5. So left to right are your x's, and going left is subtraction. And then you go from here and go up 1, 2, 3. Up is addition to the y's. So there's your translation rule. They took the original ordered pair, changed it, so they subtracted 5 from the x's and added 3's to the y's. Now, how do you verify it's an isometry? Remember, isometries are the same exact size, so we have to make sure. Well, if we count BC, 1, 2, 3, 4, BC is equal to 4. Well, how much is B prime C prime? 1, 2, 3, 4. So since they're the same length, that's how we verify it is an isometry. Example 5. Here we have the vertices of triangle ABC are at 1, 2, 3, 0, and 5, 3. We're going to rotate 180 degrees about the origin. So what I like to do is put these in a list. There's A, and this is going to be more helpful when we get into the compositions where we're doing more than one of these transformations at a time. Now, what we're going to do to all these ordered pairs, if we're rotating it 180, well, the rule to rotate 180 is that you take the opposite of the x and the opposite of the y. So we're going to apply that to all of these points. To get A prime, we need opposite of x, opposite of y. B prime, opposite of x, opposite of y, opposite of x, opposite of y. Now we're going to graph this. So A, -1, -2, -2. There's A prime. B is at -3, 0, B prime. And C prime is at -5, 1, 2, 3, 4, 5, 1, 2, 3 is C prime. There is your triangle after a 180-degree rotation.